Today, we talk about electricity. Let me give you just an idea. Well, the word electricity is coming from electron, right. Electron is only the subparticle inside the atom, which simply transfer from one atom to another. For example, you studied, this is the latest atom model as an example. We have the nucleus. The nucleus contains protons and neutrons. Protons and neutrons. And these are embedded or stick inside the nucleus. They cannot move. And around the nucleus, there is the electrons spinning in all dimensions. If you figure this one, and I say in all dimensions, they're spinning all here. We have infinite number of dimensions where the electron, they simply spin around the nucleus. My idea is what? The total charge of the nucleus is positive. Because you studied that, neutron has no charge, right? So, and this is negative. And there is something between the nucleus and the electron, which we call by electrostatic force. This is electrostatic force is due to the electricity. There are two different charges. They attract, right? That's why, let me explain this. This is the atom. This is simple, this is just simple. Now, you study, for example, in chemistry, that the atom could be actually inside the atom, there's a same number of protons, positive, and same number of electrons, which is negative. So we can say, in that case, the atom is neutral. Neutral means, that doesn't mean that there is no charge. No, there is a charge, but the positive charge, cancelled by the negative charge, okay? The total. We can say the net charge or the total charge is zero. Now, for example, this is the atom. I'm going to tell you just a story how we start with the electrons. If you consider, for example, this is something chemistry. If you consider, for example, here we have a sodium. We have 11, 23. You know, this is atomic number, mass number. Yes. So, number of protons here, if you ask yourself, is 11. And number of electrons is also 11. Why? Number of neutrons is 12. 23 minus 11, okay? Now, we say this is the same number. This is because by the atom. Atom is naturally neutral. Yes. Why? If this atom losing one electron, it will turn into
ion.
Yes, ion. So we have an atom, now becomes, how is it? It's Na plus only. Number of protons now, 11. Electrons, 10, barakallah. Neutron doesn't change, 12. So this means this ion is losing one electron. So that losing one electron, that means that electron transferred from the sodium atom into another. This transfer of electrons simply what we call by the electricity. That's it. Sometimes we call by the transfer of ions. Ions mean charged particles. Okay, Shabab? So I need to tell you something. Atom simply can transfer into positive ion or negative ion. It will transfer to positive ion when it loses electrons, and into negative ion when it gain electrons. But pay attention, it never, I focus on this, it never lose or gain protons or neutrons. Because they are tightly bound inside the nucleus. They are here, they cannot move. Okay, Shabab? They are always settled or embedded inside the nucleus. Don't think that there is a protons moving up or down. Okay, Shabab, this is the idea. Right. Now, let me continue. Now you know that. So according to this, we have two different charges. Positive charge, negative. And you know the situation or the rule. Always the like charges repel and unlike charges شباب كنا نسمع عن الكلمات هذه. الشحنات المتشابهة تتنافر والمختلفة. This is the formula. صح يا شباب? So this is the idea. This is So if you have, for example, positive with positive, these they will rebel, and positive with negative, they will attract. This is just like the magnet. We have a north pole and the south pole. Okay. Now why I'm studying here? Because I want to say something, Shabab. We don't care about chemistry part here. We care about the physical part. If you have a pen, which is made of plastic, and you rub that pen with your hair, and you make it close to the small piece of paper, it will stick with it. That means there was a charge on it, right? This charge is coming from rubbing that plastic with wool, with your hair, which is in the form of wool. ترى شعرنا بيشبه الصوف يا شباب. صوف الغنم هو بيشبه شعرنا بالضبط. You got the point يا شباب? It says, so this is the idea. If you rub two objects, you can feel sometimes if you see يا شباب, if you walk on a carpet at home and suddenly you touch the handle of the door, you see that it's sometimes sharp. Because especially if you walk just like a crow, تزحف وزحف على السجاد صح؟ This is a kind of rubbing. هذا نوع من الاحتكاك من يعني الدلك. At that moment there will be some charge in your body, and this charge, when you touch the handle of the door, it will discharge directly, and you feel that slight charge. صح يا شباب؟ نشعر فيه احنا كلنا أحيانا. This is the idea. Let us start. Now this is it. Our title today, يا شباب, it's very simple and straightforward for you. By the way, I already bought this for you, right? You will receive it in the blackboard. Okay. Now I'm going to show you some things, and we just discuss it, and we go further. The first one, you see what is inside here? Okay. So this is my electricity part 1, chapter 20. There's some pre-lecture material, you can go through it as usual. I'm going to just here say, we will discuss the charge model and use it to explain basic electric phenomena. We calculate the electric force between the charge using Coulomb's law. You know that. You took it last year. The electric field due to the different charge distribution. This is my measure case. Now let us go. Can you explain this picture for me? Why simply, when you rub your comb with your hair and make it close to the stream of water from the tap as this, you see that stream is bent. You try this at home, you can find it easily. Yes. Because it's very thin stream. يعني خلوه يا شباب خط رفيع من الماء، ما تخليه خط سميك أو كثير. Okay? This has happened due to what? Explain it.
Due to the electricity.
Okay, what is the relationship of water with electricity?
Different charges.
How? What is the water charge?
Molecule in water.
What is it?
There are different charges, positive and negative.
In the water. So when we drink water, we drink charges?
No. Actually, the water, there is a back and forth reactions inside the water, so it converts to a
Muhammad, this is not what I'm waiting for. I'm waiting for something, there's no back and forth reactions. There is something, the water is called polar molecule. You studied this in chemistry.
Yes.
Yes.
That's why the water is a conductor of the electricity. You know, for example, that the water is made of 2 hydrogen and 1 oxygen, right? But here, this is oxygen, and this is the hydrogen. Pay attention, ya shabab. Now, there is some, I think, 104 angle, blah, blah. I'm not care. Now, we have something called by electronegativity. سالبية الكهربائية.
Yes.
We found that the electrons normally will be at the center here. between these bonds. But due to the electronegativity, high electronegativity of the oxygen, it will shift the electron partial to where? Towards the oxygen. So there will be a partial sign, negative sign on the oxygen, and a partial positive sign on the hydrogen. That's why we call the water as a polar molecule. هو polar بوصل كهرباء يا شباب. And furthermore, if you have water molecules like this, I'm sure that you studied this. If there is another water molecule, there is something called by the hydrogen bond between this and this.
Yes.
Why? Because this is already negative and this is صح يا شباب? You studied this.
Yes.
So now, first of all, this calm, when we rub it with our hair, it becomes charged. There is a charge. Now this charge, يا شباب, simply, suppose it is a positive charge. Water is a polar. Just say polar, that's clear. Polar, that means there is different charge. What happened? The negative charge they will attract from the water. And the positive charge they will repel. You follow that, ya shabab?
Yeah.
That's simple. So what happened? It will bend according to that. It will bend. By the way, you try to do this with oil, nothing happens. Because oil is not polar. Yes, you see the idea, Shabbat? This is the first thing that we need. Okay. Now this is it. The charge model of electricity explains this force. Of course, there's a force, we say that electrostatic force between two different charges. Let us proceed. This we already explained. Now I will repeat again. See, Shabbat, this lecture or this lesson, most of it is something just like a period knowledge, not more than that. You'll figure it easily. See, first of all, what kind of electric charge? What are the kinds? We have positive and we know it from the atom model. We have the positive in the nucleus and you should watch the following. The number of protons should equal the number of electrons. That's why the atom is neutral here charge. There is no charge in the atom. Now, what is the positive ion and its charge? Positive ion, that means the ion that is an atom losing one or more electron. Negative ion is an atom who gains one or more. Okay, Shabab? Now, positive ion, follow with me here. If you count, we have 5 protons and how many electrons? 4. So it is positive, right? Just like if you say plus 5 and minus 4, it will be plus 1. Here, in negative ion, we have 5 electrons and 6 electrons. So negative 6 and plus 5. So the answer is? So it is negative ion. So simply, I want to say something. Ion is an atom. Either lose or gain electrons. If it loses, it becomes positive. If it gains, it becomes negative. Okay, I want to say something here clearly. If we compare between the here protons and electrons, by the way, we don't mention neutrons. They are not related here. Okay? You should notice the following. Both, they have the same charge. The charge of electron is not equal the charge of proton, but they have different masses. Simply, the mass of proton, see, it's in the range of 10 to the power negative 27. And this one, 10 to the power negative. If you divide this by this, you find that one proton has a mass of 1836 mass of electron. So the proton compared to the electron is really massive. كتلة البروتون يا شباب تعادل كتلة 1836 ايش؟ You can do this. Just divide this by this. اعملها بالكالكوليتر بتطلع معك الرقم. طبعا يا شباب negative 31 and negative 27 is about 1000 different. You figure it out. طيب. This is what I'm saying about this. That's why we don't care about the protons as particles or as moving charges, because they are so heavy. We think, oh, electrons are so light. So the electron can simply jump from the one atom to another. This one already heavy and already settled inside the nucleus. to get the protons, you have to break the nucleus, which is another here situation. We don't. It's not related here. Okay, Shabab. Tell me if there's anything we can solve. Okay. I want to show this one. Now, we know that like charges repel, unlike charges attract. Now, what is meant by the neutral? Number of protons equal number of? Okay, and then neutral does not mean no. Yes. Be careful, Isha. When I say neutral, I mean number of protons equal the number of electrons. So we can say here, we have the charges here, and we can't say that there is no charge. How plastic rod and wool acquire charge during the rubbing process. Here I want to show you something. See, Ishba. I will consider the following. Suppose I have a plastic rod, like this one. I need to explain this for you. And I think you did this experiment before. When you rub that plastic rod with a piece of wool, and you rub the same plastic rod with a piece of silk, we have different behavior. Let me show you something. When you rub the plastic with a piece of wool, the plastic will gain electrons. So it will become negative, and the wool becomes, this will lose, and this will gain. Let me explain this for you. This is natural. We have both neutral, the wool and the plastic. That means neutral, number of protons equal in each of them. Counting 1, 2, 3 positive, 3 negative. Okay? When we rub them, just like this one, we will have more here now, more electrons in the plastic rod. Count them. 1, 2, 3, 4, 5, 6. And how many? 3. So we have 6 electrons. So this is the total charge is, and here the charge is what? Is positive. If we remove them, we have this is extra 3 electrons, and here extra 3, or we have 3 positive charges. This is the way how they charge. My idea is, see, Ashba, when we rub the plastic with the wool, the plastic becomes negative charge and the wool becomes positively charged. But when we rub the plastic with the silk, the opposite happens. The silk becomes negative charge. Can you justify it for me? Can you tell me why?
Because the material.
Sorry?
Material.
You?
Material for the silk.
Yeah, what is it? This is both cloth, by the way. Piece of cloth. الحرير والصوف بيشبه بعض يا شباب صح؟ But why this is different behavior? By the way, I explained this for you. We have a different behavior because we have different force of attraction between the nucleus and the electrons inside the atom. In the case of wool, and plastic is stronger than the wool. It will acquire the electrons. In case of silk and plastic, you know the silk is made very fine threads. خيوطه بتكون دقيقة جدا زي يا شباب خيط العنكبوت. And this one, the atom is more stronger, or the force of attraction between the electrons and protons in the nucleus is more stronger than, so they will acquire the electrons. This is natural. This is something natural. Just like sometimes in chemistry, you can say, oh, there are some trends about the reactivity of the elements. You can say, sodium actually is less reactive than potassium. So if they react with the water, which one will produce the hydroxide is potassium? We can say, is the man here, is the guy here. Why? Because it's stronger than the sodium. The same thing we have. Which one here is the stronger? The plastic, so it will acquire the electrons. Which one here is the wool, or sorry, the silk, it will acquire the electrons. Just like in life. By the way, Shabab, all of us, at your family, for example, you are weak with your elder brother. You lose for him. He can simply take anything from you. For your younger brother, you are the stronger. You can't take also anything from him, right? So you lose for someone and you gain from someone. The same thing we said. Okay, this is the behavior. Okay, is that clear for you? One more point. How many positive charge we have? How many negative? So this is called conservation of charges. The total number of charges before dropping and the total number of charges after should be the same. Or the number of electrons lost by one substance should equal the number of electrons gained by the other substance. Or we can say simply, Shabab, the charge cannot be either destroyed or vanish. It will change from one object to another. انتوا تعرفوا يا شباب الشحنة ثابتة. Number of charges should be equal. So number of gained charges should equal number of lost charges. واضحة الفكرة؟ So this is, I will mention it here. So charge can neither be created or destroyed, you know it. Okay. I need to explain this now. Can you tell me what is different between insulators and conductors? We know that conductors conduct electricity or allow the charge to pass through, and insulators do not allow. Can you tell me why? يلا يا شباب. I will write this while you're thinking. Allow electrons to pass. ايش؟ No, not necessarily. We don't, that Polar number for chemistry. Don't stick with it. Do not allow electrons to pass.
Have a free electron.
Yes. Which one of them?
Conductor.
Yes. You see, Ishba, from the construction, internal construction, we see that all the conductors, they have an extra mobile free electrons. I intentionally mentioned the word mobile. متحركة يا شباب. So they can simply change, here move from one atom to another. But in case of insulator, the valence electrons are tightly bound. مربوطة مظبوط يا شباب. They are immovable in this case. So what we have, they are seated inside. So in conductors, due to the structure, these conductors, they have here a lot of mobile free electrons, they can move easily. And in the insulators, we have the valence electrons, they are tightly bound to the atom, so they cannot move. And I want to give you something more. Even the conductors, all of you, they are also different from each other. We have the conductivity, for example, of copper is better than aluminum. The conductivity of chromium is better than nickel. You got the point about this one? So this is the idea. So here I'm going to say for insulators, no free mobile electrons. And here there's free mobile electrons. These electrons make it conductor and these electrons make it insulators. Okay? Fine. Now let's go to the polarization. See, in polarization, we know that if we consider we have a neutral object, we know that all the positive charges mix with a negative charge so that the total net charge is zero. Now I need to explain this for you before I explain something. So pay attention. If I say I have an object, just like this is a metal sphere, it's a neutral. When I say neutral, I mean that all the charges, they are mixed, right, Shabab? Like this. Just draw it like this. So what we do, simply, if we bring a charge rod and make it closer to that metal sphere, this charge rod will affect the charges on the sphere. So what happened? This is my sphere again, and this is my charge rod. Suppose it's positively charged. Yes, here you'll find all the negative charge will accumulate at the closer side, right?
Yes.
And all the positive charge accumulate at the furthest side. This process of separating negative and positive, because by Polarization. You just separate the charges. Before there was mixed, and then you are separating. You got the point, Shabab? How is it? The separation of charges by any means, by any source. This is called polarization. That means there is now two poles, positive and negative. You got the point, Shabab? Okay. Let me show you. Here, as an example, here we have the neutral sphere or the object. This is, when I say neutral, I mean we have 3 positive, suppose, and 3 negative. But when we simply bring a positive charge rod closer to it, all the negative will accumulate at one side, and all the positive will accumulate at the other side due to attraction and repulsion. So this process is called by here. And I want to tell you something, Shabab. You will find here the negative charge on the sphere is closer to the rod, so it will strongly attract to the rod. And this one also, it will. I need to say something in this. Pay attention. Here we have attraction, right? And here we have repulsion. Tanafur. Can you tell me why the attraction force here is more or is bigger than the repulsion force? And this is obvious from the arrow. You know, this is a large one, this is a smaller one. Yalla ya shabab. Why the attraction is more than the repulsion in this case?
الجسم اللي جبناه الثاني اللي هي العمود يكون في قوة أقوى من الجسم. نفس اللي يمشي شوي في السلك واليوم.
لا يا عمي لا. لا بديكم نفكر فيه بسيطة يا شباب. يس.
قوة الجذب حق يعني اللي تحت مو زي اللي فوق.
طب ليه؟
فوق يبقى بسبب الجسم اللي فوق.
ترى ما في تلامس فوق. ديروا بالكم. There is no physical contact here. But you should think it يا شباب. Simply yes يا شباب. الله يرضى عليك. That's what I'm saying. Say يا شباب. You know it. والله أنتم بتدرسوها. يا شباب, which is closer? This one or this one? صح؟ This is closer. أنا عارف كثير منكم بفتح في المسافة. بس ما بده يرفع يده ويجاوب. صدقوني عارف إن زميلكم جاوب. إنه تشجعوا لا بس أنتم ما بدكم تجاوبوا. إيش أقول أكثر؟ This is simple. صح يا شباب ولا لا؟ Due to the distance, that means as here the distance become closer and closer, this force, either attraction or repulsion, it will increase, right? And when the separation is more, here the force will be less. Did you know this is why this is now the introduction of the Coulomb's law, which we are going to study. لا راح ندرس Coulomb's law اللي انتم درستوه العام الماضي وحليتوا عليه مسائل. That's what I'm looking for here. Now you will see by yourself. Okay. Is there any question in that? Just let me finish. Then after that, ya shabab, we will have, see, after we solve this one, we have Coulomb's law. So this is introduction, but let me just finish this idea. Now here, what is the electric dipole? We know that. Di means two. Dipole, that means any object that contains two different, we can say, kinds of charges, positive and negative. You can consider it as just like this. Di dash ball. Two balls, okay? Now what is induced electric dipole? The same thing that we explained it now. Induce, that mean, in Arabic we call it حفي يا شباب. This dipoles produced from another source, just like the charge rod اللي احنا أخذناه قبل شوي. Now, this one يا شباب here, this rod induce all the charges here to distribute like this, right? So this is we call by induced dipole. Why it is induced? Because it's coming due to this rod. If we remove the rod, what happened? It will go back mixed together, right? So this arrangement of separation of charges there is something, there is a reason for that, which is the rod. You just erase the rod, it will not last forever like this. It will mix again. Okay, Shabab? That's why we got by induced. Pay attention. It is the same thing. This is my sphere. And this is positive. In case of positive, you extend all the negative, they will accumulate here. And all the positive will accumulate. So this is what I'm saying now. Now we agree that this force is greater than this force due to the distance, right? As we say. Now this is attraction and this is repulsion. And this is important. Now, what is the permanent electric dipole? Permanent means دائم. ترى بالمناسبة induced ذكرتكم نسميه باللغة العربية حفي. حف الشيء يعني it's something like that. Here the permanent something permanent, just like the water molecule. I explained this for you. They have different electronegativity. So there will be a partial charge, negative charge on the electrons and the oxygen, and partial positive charge on the hydrogen. Okay? Now, we have one more point. See, what is the charge quantization? سموه تكميم الشحنة. حتى باللغة العربية شباب التشارج اسمها شحنة وليس شحنة. الشحنة اللي هي الكاربو هذه. شحن جوي وشحن بري. أما شحنة باللغة العربية هي charge, electric charge. Who can tell me what we mean by charge quantization? Okay, I'm going to give you an example. See, we always, you studied this in biology now, that your body is made of cells, right? For living things. For non-living, they are made of atoms. Can I say that my body is made of 13 and a half cells?
No,
Why?
because there is no half cell.
That's correct. You agree about this?
Yes.
The same thing we have in quantization, تكميم. The small charge which we have it, or the unit charge is the charge of electron. The charge of, it's the smallest, it's the cell. So, I will consider this charge, which is 1.6 times 10 to the power negative 19 coulomb, is unit charge. This is your cell, okay? So the charge of any object is an integer multiple of the charge of the electron. So I couldn't say my body is made of 13 and a half electron. There is no half electron. You got the point, Teshaba? How is it? The same manner, the same mentality here. We have the electron is the smallest charge that cannot break anymore. So anything in this world, it should contains always an integer number of electrons. Integer multiple. When I say integer, I mean just only number, without fractions, without decimals. You got the point, Shabab, about this? This is what we call by quantization. تكميم الشحنة يا شباب. شحنة أي جسم هي عدد صحيح من شحنة إلكترون. لما نقول عدد صحيح نقول 10 100 1000 500 لكن قلت 100 ونص this is wrong. إن شاء الله واضحة لكم الفكرة. So يا شباب, how many times the charge of the single electron object has? طبعا that's why see شباب, I can write now, there is a formula. This is the charge of object is equal to plus or minus, because this is here, n times the charge of electron. N here is the integer. When I say integer, عدد صحيح, and E here, this one. So always we have 1, 2, 3, blah, blah, blah electrons. We don't have 1.5 or 2.5 and etc. Okay? So you can write, if you want to say that charge quantization, charge of any object is an integer multiple. Integer multiple هو يا شباب مضروب صحيح of electron charge. Of electron charge. God, this is here, we translate it to this one. Okay. Is that okay for you, Shabab? Now, what do you think about it? What you said, all think this is already passed with, right? Into أخذتوها الشيء. It's not. I'm just refreshing your memories, not more than that. Okay, barakallah. There will be some self-reading. This self-reading, Shabab, it's an optional. You can read it and you can run that movie, see it later, because this is here. I try to make it here before, but as usual, quick time is not available, so you can do it at home, never mind. This is self-reading is not included, by the way. This is for just here as curriculum actually material. Just you can take some advantage of it. Okay. Now, there's a question. Read the question and tell me. If a charged plastic rod is brought near an uncharged metal rod on an insulating stand, an uncharged metal ball near the other end of the metal rod is attracted to this end of the rod. Can you tell me? Yes, Ahmed. You know why?
Because the negative charge will propel from the rod,
Okay.
and the positive charge will attract to the rod. So the negative side will be on the right side.
Okay.
And that charge is uncharged pole. So
Yes.
and the same thing will happen. They will exchange to.
Barakallah. That's correct. Yes. See, Shabab, let me draw the image that before this one. We have, you see, uncharged metal rod. You got the point? Uncharged, that means we have positive, negative, positive, negative. Okay, barakallah fikum. And we have this metal ball, also positive, negative. This is uncharged, this is uncharged. Okay? Now, I put this charged rod beside this one, closer to this one. Oh, this is negative. Yes, you will see that all the positive, they will accumulate here. This is polarization. And all the negative, they will accumulate. Before that, it was neutral with a neutral. Now there is more charge, more negative. So what happened to this one? It will attract. By the way, the neutral will attract to the charge normally. That's why, you did this before, that you stick the balloon with the wall. We consider the wall as a neutral. How you rub the balloon with your hair or the piece of cloth and you make it close to the wall. What happened? It will stick, right? It will stick for some time because we consider the wall is a neutral. It will attract to the charge on the balloon. This is the same thing that we have. Okay. Now, let's start with the Coulomb's law. From this law, Shabab, by the way, I'm going to give you just only the idea. One of the ideas that we explained. Coulomb's, or Charles Coulomb, is a French scientist. He found that the mutual forces between two charges, when I say mutual, I mean either repulsion or attraction. بسموه القوة المشتركة يا شباب. ما في داعي نقول قوة تجاذب أو قوة تنافر دائما. Mutual forces, okay? The mutual force between two charges is here, depends on the following. This force is direct proportional to the product of the two charges. Okay? So more charges, we have more force. Attraction or repulsion, mutual. And we found also that the force is inverse proportional to the square of the separation between the charges. So more separation, less force, right, ya shabab? Okay, according to this, these two results, this is the statement of Coulomb's law. Simply, force, or the mutual force between any two charges is direct proportional to the product of these two charges and inverse proportional to the square of separation. Not to the separation, to the square of separation between them. Okay? So if we write this in the form, I'm going to write F is equal to K Q1 times Q2 over r square. You took k, it's constant, it's called 9 times 10 to the power 9. Okay? I have a question now. You remember this formula, right? This is a constant. Why I put that absolute value? Yes,
Because there is different charge, like proton is a positive charge and electron is a negative charge.
okay.
So to make it easier, so you put an absolute value to just give a positive number to calculate the rest.
So we don't care about the sign.
Yes.
So how we show the sign, ya shabab?
Who's it?
No. See, Allah Ta'ala. This is a question, yes. First of all, we put the absolute value. That means we don't care here mathematically about the sign. We care only about the magnitude of force. How much is it? But you should know from the question, if it is positive and positive, you will tell me this is repulsion. Okay? If it is negative and positive, you will tell me this is? That's it. But the amount of force is the same. The amount of force is the same, Shabab. So this will give me simply here the magnitude of the force. What type of force is it? Here we just put it according to the sign, according to the sign. Maybe I'll ask you, find the magnitude of the force. You say the force 500 Newton. Okay, what type of force is it? That depends on the sign. If it is positive, positive, or positive, negative, or negative, negative. Okay, Shabab? This is one point. Let me show you something. In this problem, I'm going to say something. Suppose we have, this is positive 5 coulombs, and this is positive 5 coulombs. Okay, Shabab? And this is, suppose this is 1 meter. You find F simply. F, you say Q, 5 times 5 over 1. So can I say it's 25K? Just leave it. Okay? And if I have negative and positive, this is 5, negative 5, and this is 5. Also F will be, right? But, so how they are different?
That's all.
What type of force? This is repulsion, and this is? Okay. But the magnitude is the same. This is one point. I need to say something, Isha. We have this is repulsion, right? Can I say this is F1 and this is F2? Sorry. F2, 1, and this is F1, 2. What I mean by this one? The force of charge 1 on 2, and the force of acting by the 2 on 1. Here, when I say mutual force, ya shabab, I mean these two forces, they are the same. They are the same. Don't slip in that trick, ya shabab. This force is the same as this force. That's why we call it by mutual force. قوة مشتركة. I will make it clear for you. انتبهوا بارك الله فيكم. I have charge of 100 coulomb and another charge here of 5 coulomb. There will be attraction, right? Now, F12 and F21, how they relate? Whether they are equal?
Yes.
But this is 100 and this is 5.
هو مشترك.
Allah is. You got the point? This is what, Shabab, don't slip in this one. لا تنخدعوا بهذه الكلمة. This is a mutual force. This is coming from combination of two charges, not from one precisely. يعني الآن تنظر أنت هذا الكومبينيشن كلها كم 105 للاثنين. لا تنظر لي والله هذه 100 وهذه ايش 5. So we say here يا شباب simply F12 equals, that's why we call it by the mutual force. We call it as a mutual force. Of course now, finally, we expect one of these questions will come in exam. Either to find the charge, or to find the separation, or to find, yeah shabab, this is the force is a vector. This one will give you the magnitude and the direction according to the type of the charge. Is that clear? Right. You'll find that there is no problems on these. But this is the formula for you, and everything is given for you. R and K, everything. If you have any question, ask me. going to solve this quickly because we try to finish this lesson today. We're almost done. Pay attention. These are good, so good questions. And we expect them because this is from your textbook. In the question 1, in each of the following cases, an identical small positive charge is placed at the black dot. In which case is the force of this small charge? Force in the small charge is the largest. We have here positive. We have here positive. Okay? Can you tell me why A ya shabab is the largest? Look at it. Go ahead. Yes.
ان من على اليمين السالب يجذبها ومن اليسار يصير تنافر بينهم نفس الشيء.
So طب هنا سالب يجذب هنا سالب يجذب. إيش
ضد مكانها هذه اللي تحت الضل مكانها. نفس القوة من اليمين لليسار.
طيب خلينا نجسم. يس.
في A عندك البوزيتيف قاعد يدفعها الى جهه النيجاتيف والنيجاتيف نفس الوقت قاعد يجذبها لنفس الاتجاه فصار كقوتين.
This is one point. Okay. See يا شباب. This is the RA. By the way, I'm going to here. This is here. They cancel each other. صح? Okay? But say انتبهوا معي يا شباب. Here, this one has a large force with negative. But what here on the other side has also small force of repulsion. Okay? Now here we have a shabab repulsion, a large one with this one and a smaller one with. So what is confusing these two cases, A and C? Pay attention. In A here shabab both they are close. لينهم قريبين صح؟ هنا واحدة قريبة واحدة ايش؟ لما تكون بعيدة يكون الفورس ايش؟ less. Okay? So the answer is A. I'm so sorry, I try to, but see sure. In this case again, يا محمد, and all of you have to draw this one. لازم ترسمه يا شباب. You figure it out? And in purpose here, لازم ترسمه. البعيد القوة الصغيرة ارسمها سهم صغير. والقوة الكبيرة ارسمها سهم ايش؟ أكبر for that. طيب. You will continue that questions. I'm not going to go through it. خليني بس اشرح يا شباب هذه الجزئية الأخيرة ولا بعد. Okay. See, this is the last point. We have it, and there will be some questions, and we done. هذا هو simulation. Okay. معلش تحملونا دقائق بس إن شاء الله وياكم يا شباب we done. Because they are related together. Now we've done about the force. Let's go to the electric field. Pay attention, Ishmael. Just like the magnet, every charge, whether positive or negative, there is a space surrounding the charge, and where in that space, the force of the charge, this charge, is appeared in that or exists in that space. Okay? So this is suppose we have capital Q. Q stands for the charge. If I have positive charge outside, it will not affect. If I have positive charge enters, what happens? It will, just like a magnet, okay? Now, this is the general one. The electric field, simply, the electric field is the space surrounding the charge where the force of the charge, electric force of the charge, appear or exist in that field, in that space. Now, we have more precise question. The electric field at a certain point, if I say, what is the electric field at point A? Whether it's the same as the electric field at point C?
No.
Oh, no. So what we do, ya shabab? Pay attention. Electric field at a certain point is the force acting by the main charge on a test charge placed at that point. Now, what is the test charge? شحنة الاختبار درستوها يا شباب؟
Yes.
It's a small positive charge. بيسموها plus Q. This is very small charge that has no electric field. Almost. Okay? This is conventional. هذا اتفاق بين العلماء يا شباب. بتقول لي طب ليش اخذوا بوزيتيف؟ اتفاق عشان يوحدوا هذا. ممكن تاخذ نيجاتيف. The same thing. Doesn't change. Okay? So what do you see? شباب, what is different between A and B, C here? If you assume that there is a positive charge at A, how much force of repulsion? It will be a large force. If you put a positive charge at C, the force of repulsion will be less due to the separation, right? So simply the electric field at A is the force of repulsion acting on a discharge placed at A. And the electric field at C is the force of repulsion between the main charge and here on a discharge placed at C. So simply, I'm going to say the electric field, pay attention, is the force over Q. Force acting on a discharge. But the force itself, we took it now. The force is what? Is K, Q small, Q capital over R squared. Over Q. Because this is the force between this one and this one, right, ya shabab? Capital Q and small. So what we have in here, this will cancel with this. So finally, E will be equal K, Q over R squared. You follow this one, ya shabab? This is a Q, is a simple. I just put it, you just put whatever you need. اكتب يا شباب Q زي ما تشاء, small, اكتبها S, اكتبها M, doesn't matter, change. But it shows. أنا بحب أكتبها capital Q, it means this is the main charge. Who's acting on the test charge. واضح الفكرة؟ Yes.
حطيت علامة القيمة المطلقة يعني لازم تكون موجبة؟
Yes. You know why? Because this one, you can be either repulsion or, right? Okay. Now I need to say something, and this is done. That's why when we draw, barakallahu fikum here, the electric field of the positive charge, we draw it like this. This is a positive charge, the electric field is a line that goes outward. And for a negative is the line that goes, you took this, right? Can you justify for me why now? ليش يا شباب نكتبهم كده؟ نرسمهم كده، ليش ما عكسناهم؟
لأن التست
أيوة.
بوزيتيف سو
الله يسعدكم. أي نقطة حط الديسشارج هنا وين بتروح؟ هذا الإلكتريك فيلد، هذا اتجاه. هنا حط الديسشارج وين راح تروح يا شباب؟ طيب راح أعطيكم one more point. See, to know the direction of electric field and at any point you just place a discharge from that one and see where it goes. Simply, I'm going to show you something. See يا شباب. This is the last point. Suppose I have two charges like this. I have a positive and say negative. The lines, I draw them like this. I need to say, what is the direction of electric field at point A? What is the direction, for example, at point, B, at point C? That's simple. Always, to find the electric field, you assume what? Test charge. Okay? لو حطينا هنا test charge، وين راح تروح يا شباب البوزيتيف هذه؟ راح تبعد، صح؟ This is the direction. لو حطينا هنا test charge، وين راح تروح؟ This one it will go straight. صح يا شباب؟ ما راح تكون، لا هي مش في الوسط، هي it's actually moving. صح يا شباب؟ Always to find the electric field or the direction of electric field at any point is nothing but the direction of test charge placed at that point. بارك الله فيكم. واضحة؟ طبعا the question that indeed there will be question in these. Nobody will ask you about this. يعني هذا لو جاكم أسئلة مساعدة ممكن بتكون. إن إحنا we already know that you took this last year. فما تسألني تقول لي والله هذا القانون كيو على ار سكوير ولا ما أخذنا مسائل عليه. راح تجيك مسائل عادي جدا وتعلمتوا عليه. So this is what is new for you now here is the next lecture. This will be new. إن شاء الله تعالى. طيب يا شباب, we stop this here today. Shall we find everything here inside it here? There will be some questions. Go through it. آخر شيء هذا this is a simulation. إذا فتحته أنت you change this one with this one, you will have different electric fields. هذا شكل الالكتريك فيلد goes from positive to where؟ شايفين شكله كيف يا شباب؟ and that's it. يعطيكم العافيه. See you ان شاء الله next week.